Okay, this is lesson 43 for Algebra 1, comparing functions in different ways. Okay, so we've looked at different ways of looking at different graphs, and we've looked at three major types of graphs in our class. We have linear, quadratic, and exponential, right? So we know how to graph linear and quadratic now. And exponential, we know what it looks like, but we don't know how to graph it yet, but that's fine. But we all know that there's this thing called domain for a function, right? The ingredients or inputs, and we also know intervals of increase and decrease, and so we could figure out what functions are doing throughout the course of their existence on a coordinate plane. So we're going to figure out what are the differences when we compare two different functions in regards to those things. So these are the steps for this lesson. You could compare them algebraically. We're going to compare them also graphically and also by a table. So these are the steps. If you're on the video, pause this and write these down. I'm going to move on right now. Alright, so numbers 1 and 2, these are actually one big problem, okay? So I'm going to, for your homework, there's going to be directions. You're going to compare them like this. So I'm just going to show you three ways we do comparisons today. This is the first way, which is algebraic. Okay, so we have two equations here. We have the first equation, which is this right here, and we have a second function that looks like this, okay? So we know by our steps that we're comparing them algebraically, which means we just have the equation. So first thing we do is we want to find what's the x doing on each of these, okay? So on this first one, x is to the first power, and the second one, x is to the second power, okay? So we would write x is raised to the first, and we're actually doing a little bit more writing today than anything. So we know what we're comparing to the first power. Okay. And on the second one, we know that x is raised to the second. Okay. When we look at this type of equation, or each type of equation, when we have anything to the first power, we know this is a linear graph, okay? Anything to the first power is linear. Anything to the second power is quadratic. What's anything to the first power? Linear. Anything to the second power? Quadratic. Okay, that means that if I were to compare both of these equations, I know that the first one, if I were to graph it, we don't know what it's going to look like yet. But if I were to graph this, just really quick, it could look something like that, okay? I'm not really looking at the specifics on how to graph. And the second one would look like this, right? Or like this. We're not looking at the specifics yet, though. Okay, so, but we know that, so that's good. Linear graphs, we know that if I were to graph this, if I were to just do a simple graph, let me get a thicker line here. Okay. If I were to graph this, I know that the y-intercept is 1, and that the slope is negative, a negative sign. So we know that it's going to go down 1, run 1, down 1, run 1, and so forth. And so our graph will look kind of like this. Okay. I'm not looking for a perfect graph on tonight's homework at all. I just want you to think about what it's going to look like in your head, or you could just do a rough sketch like that. All right. And then the quadratic right here, y is equal to 2x squared plus 4x. I know b is 4 and a is 2, so negative b over 2a would be negative 4 over 2 times 2, which is negative 1. And I know it opens up. So that's enough information for me. If I know negative b over 2a is 1 and it opens up, or negative 1, we know that our vertex is going to be someplace around here, either here or it's going to be up top here. So I'm going to assume it's down here and it's going to be opening up, okay? So these are my, a rough sketch of each, okay? So looking at this, what's the domain of my first equation? How far to the left and right does this linear graph go? What's my domain here? It goes from negative infinity to positive infinity, right? Does it ever stop at any point? No, okay. How about intervals that increase or decrease on this first graph? Does it ever increase? It's obvious that it doesn't increase, right? So it decreases from negative infinity to positive infinity as well. Okay? And this is all we really know when we look at this type of function, is that it's linear and we can't really derive anything else, so we know that that's what's happening on this one. On the quadratic graph, we know that it's decreasing. We know that it's decreasing from negative infinity to positive, or negative infinity to negative 1, because our vertex is someplace on this axis of symmetry here. I didn't calculate it, but I know that if I were to calculate it, it would be on that axis of symmetry because of negative b over 2a. So we would write our domain is the same, negative infinity to positive infinity, and we know it's decreasing in the interval of negative infinity to negative 1, and our increase is from negative 1 to positive infinity. Okay? And that's it. All right? That's all we're going to compare on numbers 1 and 2. So, again, we're looking at two equations. We could gain a lot from two equations, okay? The first equation, we know that, again, it's to the first power. Since it's to the first power, we know automatically it's linear. The second equation is raised to the second power, therefore we know it's quadratic. And if I were to kind of rough sketch each of these, we know what it look like that. We know what our domain and our range is, okay? So, and we know what the shape is, right? A linear graph is straight, quadratic graph will open up or down. The quadratic, we know it opens up or down on this one. How do you know if it opens up or down again on number 2? If what's positive or negative? If A is positive or negative, we know if it opens up or down. A is positive, here it's positive too, so we know it opens up. Does that make sense, everyone? Questions? Yes?
Would it be like a third power?
Yeah, that's cubic, We don't really deal with cubic too much here in Algebra 1, but yeah. Cubic kind of does this wiggly thing. It starts to do a wiggly thing where it goes up and then down and then back up again. So great question, yeah. We're going to do exponential too, so kind of like it could open just up all the way or open down all the way. So, all right, so this is the first way we're going to compare them is algebraically. So turn your neighbor and discuss how do we compare things algebraically. Here, so on these two problems, or any of them, you have to kind of use some concepts that you've learned, and you have to be able to pull ideas that you've learned before without me asking for them. Okay? Did I ask you to tell me what the power was of the first problem? Did I ask you to do that on my directions? No. Did I ask you to graph?
No.
Did I ask you to tell me domain or intervals? No. But these are things we know, right? Right? You understand? So you have to kind of think like, you have to own math. You have to say, well, this is what this means, and this is, I know these because I already know these concepts. So I'm going to use the concepts to unravel the problem a little bit. Okay, so here we go, number 3 and 4. Here's another way we could do it. So watch up here. This is different directions. This is compare the two equations graphically. Okay. So this one's easier, right? Did I have to graph any of this? No. So if we're looking at this, the first equation is what kind of equation, everyone? Quadratic. Good. And the first equation, is it open up or down? Opens down. And I got a question for you. Are there any solutions? No solutions. We know that from yesterday. Domain and range. Our domain and intervals of increase, decrease. What's our domain first? Good. Negative infinity to positive infinity. That was the easy one, right? Intervals of increase. Does the graph increase at all? What? I see it increasing. It's increasing from here to here. So tell me, how is that working? Negative infinity to 3? Is that what you guys got? Okay. And then when does it start decreasing? Okay, good. All right. That's all we know about this type of graph, right? We know these pieces of information because we're math students and we know what the concepts are here. Okay, so That's that. But what's this one? Is this also quadratic?
Exponential
Oh, exponential what?
growth.
Growth. Good. Exponential growth, right? Excellent. Okay. So we know it's exponential growth, which means that from left to right, it just keeps going up higher and higher and higher, right? It's growing exponentially. All right. There isn't anything like solutions in exponents, but we know about domain. What's the domain of this? How far to the left and right does this go? How far to the left does it go? When does it start?
Negative infinity.
Negative infinity, right? Okay. How far to the right does it go?
Positive.
To positive.
Would you all agree that this arrow is still going kind of diagonally?
Yeah.
So isn't it always going to keep going diagonally, right? So what's our domain then? When does it end? Positive infinity, right? It just keeps going to the right forever, right? Good. Excellent. Intervals of increase? This one's kind of obvious, right? When does it start increasing? Good, negative infinity, right? It could be so tiny, it could be minuscule at negative infinity, but it's still increasing ever so slowly, okay? When does it keep increasing till?
Negative positive infinity.
To positive infinity, right? This one's obvious, right? It does keep going. It's exponential. It doesn't keep going forever and then stop growing. It's exponentially growing infinitely, okay? Super easy. That's all we know about this, right? That's all we're doing is comparing them. All right, so on a test, let's say you're taking our Common Core test, you need to be able to pull this information out. Even though it's not explicitly asking you, you need to be able to look at the graph and say, oh, that's quadratic, it's negative, there's no solutions. It has an interval of increase from here to there, interval of decrease from here to there, right? And same with the second graph. Oh, that's an exponential graph. You have to be able to see that, okay? And you have to write it in words. The first graph is and writing in complete sentences. We didn't do that here, but this is something you have to start thinking through, okay? All right, so again, let's have you discuss how did we derive this information when you did it. Ready, go. All right, the last way we compare things are by a table. This one's the hardest because we don't get really a say of what it looks like, but it's also easy because whenever you have a table, remember these are pairs of x's and y's. Okay, so we have two pairs of x's and y's. So this is a table. Remember, these are like the left side are your ingredients, the outside is your output. Okay, or the right side is your output. So ingredients, and then your output is this. Okay, so what I would do when I do this is I would just make a rough sketch of what's going on, okay? So, let me draw that a little straighter, all right? So, on this one, I know that the graph's going -2, -5, which is kind of, there's a point here, and the next point's -1, -3, which looks like there's a point here, and then let's go to 0, -1, there's a point here, 1, 1, there's a point here, and then 2, 3, there's a point here. Okay, what looks like is happening on this particular graph? What kind of graph does it look like? Linear, right? And it's what kind? Positive or negative linear? Positive linear, right? So then we would, on your homework, you'd say it's a positive linear. What's the slope of this? How much is it rising and running at each point? What's the rise over run? 2 over 1, right? You all got that? How much is it jumping at each y? It's rising 2 for every 1. Did you all see that? So what's rise over run? Good. So we would say the slope is 2 over 1. Okay. So these are pieces of information you know about. Right? And domain and rate and intervals of increase, I'm not going to explain that again here. But, these are pieces of information that you know. So we know that. Now let's do the next one, which is the next table. So it's still rise. You still have your ingredients are the same, but are my outputs the same on the function? Are they the same? Yes or no? Oh, they're symmetrical. Did you all hear that? Do you see that they're kind of symmetrical? What kind of graph do we know about that's symmetrical? Quadratic, right? Okay, so just do a rough sketch, on your homework or on the test. You're like, okay, these are all points, so let's see, -2, -6, there's one here, and then it's -1, 0, there's one here, and then there's 0, 2, and right here, and here, right? So it kind of looks like this, right? So is this a positive or negative quadratic? What do y'all think? Negative quadratic, right? Okay. We do have a piece of information we could gain from it. What are the solutions? When does it hit the this, by the way, this is a point and this is a point. These are the original points I put in. When does it hit the x-axis? What are the solutions? What point is this one and this one when I graphed it? Good. What are the two solutions? -1 and 1, right? These are points that were given to us, right? We know that these points are the points where they intersect the graph, so these are our solutions, okay? And of course, in your solutions, of course, you could write -1 and 1, okay? And of course, domain and range and all that, we already know, so I'm not going to waste my time, but on your homework, you would still explain every bit of information you know, all right? So, the variety of problems will be similar, but you're going to be looking at these three methods for comparing functions, okay? So we're going to look at them algebraically, like as an equation. You're going to look at graphs. What do they look like? How are they similar and different? And then you're also going to be looking at tables, okay? And you have information. You already know about lines. You know about slope and y-intercept. You already know about quadratic graphs. You know what the open up or down solutions, intervals of increase, decrease, axis of symmetry, all that stuff, right? So, and exponential, increase and decrease, you already know about that also. You already know what it's supposed to look like. So, anyways, this concludes this lesson.